After giving you a tour of my new HomeLab hardware and infrastructure and my server rack, many of you asked, why is your HomeLab so big? And what services are you self-hosting in your lab? Well, I hope you have your notebook ready and your buzzword bingo cards. It ranges from dashboards with and without data, to hypervisors to run all of my virtual Windows and Linux machines, to an NAS running quite a few storage services, to internal DNS with network-wide ad blocking, to network management from the edge firewall all the way down to VLANs on the switches, to Docker containers that are running inside of multiple Kubernetes clusters, to Git Ops so that I can treat my infrastructure as code, to CI and CD to build and deploy my code and infrastructure whenever I want, to reverse proxies to serve out HTTP traffic internally and externally, to monitoring and logging to see how all of my services are doing, to data visualization to help see things at a glance, to home automation, and so much more. So come along with me as we check out everything that I'm hosting in my HomeLab. Did you get a buzzword bingo yet? Okay, so first up is my dashboard, or my homepage really, and I still use Heimdall. Heimdall is a really clean way to have a dashboard, if you will, of all of your favorite links. Heimdall can actually do more than this. It can actually pull back data, but I use it for links just for now, and this is my homepage. So it's basically a launch pad to get to all of my services. This might change in the future, and it most likely will, but it's Heimdall for now. And on this page, you can see a lot of the services we're going to talk about. So let's hop into my hypervisor first. Now, the hypervisor that I'm still using is Proxmox. I'm on Proxmox 7.3 right now. I think last time I showed off, I had 2 or 3 nodes, but now I actually have a 4th node, which should be coming online soon. But I have 4 nodes that do all of my virtualization. So these are set up in a cluster, but I don't have them set up in HA mode, which means I don't have HA virtual machines, but I still get the benefits of a cluster, like migrating machines back and forth, moving them around, backing them up centrally. But I chose not to do HA virtualization because, as we'll talk about later, I build HA into my services when I can. So the first node is Draco, and this is the 1U server you saw at the top of my tour. This machine has 256 gigs of RAM, it has 4 1TB SSDs, and it has a SATA DOM for the OS. And this runs quite a few virtual machines. I can go through these really quick. Photon is one that runs a Twitch stream for me. Quasar is one of my DNS servers, which we'll talk about. Hoku, Hele, Aku, Archie, Hele, Hoshi. All of these run Kubernetes, and we'll talk about that here in a little bit. But most of this node here is dedicated to Kubernetes. So the next one is Helios, and that's actually right back there on my workbench, and it's a part of my Proxmox cluster. It's an Intel NUC, and it has virtualization, so I turned it into a hypervisor. And you can see here I have 1, 2, 3, 4, 5 VMs on here, and all of these are, again, dedicated to running Kubernetes. If you notice, all of these end in -3. That's for a reason, so I can coordinate shutdowns and reboots. So in my Kubernetes cluster, I have one of each node type on one of each of my Proxmox servers. So if I ever need to reboot my Proxmox node, I know that I can reboot this whole entire node with its virtual machines and not have to worry about my services going down because they're load balanced most likely across 3 different systems. And those systems are all on different Proxmox nodes. Anyways, we'll get into that. But this machine has 8 cores, it has 64 gigs of RAM, and it has 1TB SSD, and I think it has a 500 gig SSD. And this is pretty much maxed out as far as memory goes. And obviously the CPU is maxed out because it comes with the board. But this is a more than capable hypervisor for a fraction of the power. Anyways, this is the 3rd node in my Proxmox cluster, but it won't always be. You're gonna see some changes to this here in a little bit. That's why I added my Stornator, but we'll talk about that here in a second. So next up is Hydra, and that's the next 1U server that's below Draco, and it has the same specs as Draco, which I built at the same time. It has 256 gigs of DDR4, it has 28 cores, single socket, and then it has a bunch of SSDs, I think 4 1TB SSDs that are in a striped mirrored, so they're both set up in a RAID 10, if you will, or 1+0, but basically a striped mirrored, so I get parity in performance, and then a SATA DOM for the OS. And so as we go through these, so Hoshi, this is running Kubernetes. Juno, this is a test machine. Milky Way is my Windows machine that I use for some of my Windows software. Luna is Kubernetes. Andromeda, this is actually TrueNAS, so I virtualized TrueNAS. We'll talk about that here in a little bit. Windows 11, this is a test Windows 11 machine. Swift is another Windows machine for testing. Hoku, Hele, Aku, Archie are all production Kubernetes machines. Next, you'll see K3s 01, 02, 03, 04, and 05. These machines are for my automated testing with my Ansible playbook that helps you automate and install Kubernetes. And if you haven't used that yet, it's an Ansible playbook that spins up Kubernetes for you, gives you HA automatically with just a few commands from Ansible. And so these are the 5 devices or virtual devices that I always use for testing that playbook when I make any changes. I have CI on the repo now, but it's still nice to have dedicated machines and run it locally just to make sure it works, especially for larger Kubernetes upgrades. Blazar is another DNS machine, which is Pi-hole. We'll talk about that here in a little bit. Then I have some templates and stuff like that. And then, as you can see, my 4th node now is the Stornator. So this is the Stornator that's inside of my rack. This is actually running Proxmox now. I'm so on the fence between running bare metal TrueNAS or Proxmox and then virtualizing TrueNAS again. So the reason why I'm still on the fence about virtualizing this or going bare metal is because I feel like Proxmox is a better hypervisor, whereas TrueNAS is better at storage. But if I use my Stornator as a bare metal NAS, that almost rules out virtualization for me. I get it, I know you can do it, but I enjoy Proxmox. So I might, again, turn it upside down and virtualize TrueNAS within here, pass through the disks and pass through the 10 gig NIC cards and use it that way. Still haven't decided, so just follow along to see where I go. Most of these nodes have ZFS storage. This is what I was talking about. This is the Fast 10 ZFS pool, and this is actually a striped mirror, and this is where all the virtual machines run. And you'll see backups mounted to most of these, and this backups folder is just an NFS share that's running on TrueNAS that houses all of my ISOs and my backups too. And I schedule my backups weekly. So, since we're talking about storage and NFS, I think it's time to talk about my NAS. So last year I was running TrueNAS Core. This year I moved to TrueNAS Scale. Now I did that for a couple of reasons, mainly because of Linux support, but yeah, mainly because of Linux support. So as you know, TrueNAS Core is based on FreeBSD, super solid, super great, but not great for drivers and additional things you need to install. TrueNAS Scale is based on Debian Linux, and so I moved to Debian Linux so that I can manage this just like my other virtual machines. And by that, I mean I can install the VirtIO drivers for virtualization so I can get better performance on the NIC and all that stuff that comes along with it, and graceful power shutdowns. That's probably the number one reason why I went to TrueNAS Scale, is to get it on Linux because I virtualize it and then I can install the additional software I need to shut this down gracefully instead of a hard shutdown. Now TrueNAS Scale supports all kinds of features. It supports Docker, Kubernetes, and all kinds of things you want to install and run on your NAS. Basically, you can run it as an all-in-one, even virtualization. But I chose very specifically to only use storage services. So what do I mean by storage services? I mean only services that are for storage. So what do I mean? So first of all, I'm running iSCSI on here so I can use it for block storage. Then I'm running NFS so I can attach to Unix shares. Then I'm running S3 so I can use it for object storage. And this is super popular by things like AWS and S3. I'm doing SMB or Samba shares so I can have Windows shares for Windows clients and also Linux clients. And then I'm also running it as Time Machine for some of my Mac devices. Yes, I have Macs in the house. And that allows me to back them up just as if I was using Time Machine from Apple. So the reason I choose to do this with TrueNAS is because it's all backed by ZFS. So right now I have one big pool on here that is about 20 terabytes that's configured in at RAID Z2, as you can see. And within this pool, I have different data sets, one for each type. So you can see I have an iSCSI one, I have one for applications, and that was for testing, NFS General, NFS Kubernetes, NFS Proxmox, S3 Storage, and then Time Machine. So TrueNAS with ZFS on top of it is a great platform to build all of these storage services on top of. But this is only connected at gigabit. Actually, I have it lagged, but maybe soon 10 gig for TrueNAS. Next up is internal DNS. Now I use Pi-hole for my internal DNS as well as network-wide ad blocking. It started out as just network-wide ad blocking, but then Pi-hole added the local DNS feature, which is really nice for me because I host lots of things in my internal network and I like to refer to them by name. It also helps out with certificates and a whole bunch of other things. But I actually have 3 instances of Pi-hole, and you're thinking, what the heck? How can you have 3 DNS servers? I do. It's pretty complicated, and I do this for a specific reason. So my first Pi-hole instance is a virtual machine. It's this one right here. My second Pi-hole instance is also a virtual machine. It's one that you don't see right now. My third Pi-hole instance is a tiny Raspberry Pi Zero. The way that I've organized these is that my primary DNS is this machine right here, a virtual machine. My secondary DNS is actually a VIP, or a virtual IP, that's load balanced between 2 Pi-hole instances. So it's load balanced between a virtual machine and my Pi Zero. Why did I do that? Well, 1, I wanted to learn how to use Keep Alive D, and then 2, so I wanted to be sure that if my whole entire server rack shut down, that my Pi Zero would still be serving out DNS requests. So that gives me a low power option when and if I shut things down.
Hey, is the internet down?
And so really, I have a primary DNS and a secondary DNS, but the IP of the secondary DNS is a virtual IP that those 2 share. So when one's down, it'll take over. When it comes back up, the virtual machine will take back over. So the way that I keep them in sync is by Gravity Sync. Gravity Sync will not only sync your block list across multiple instances, but it will also synchronize your local DNS, which is super handy. So the way I have it set up is I have my primary DNS, that's where I make all of my changes, and the other 2 DNS servers, 2 and 3, pull those changes every 15 minutes or so. And so that keeps everything in sync. And worth mentioning, I don't use DHCP on Pi-hole. Next up is network management, and I'm lumping into this network management and firewall. So the network management suite and hardware and firewall that I use is a UDM-SE. Now I had a UDM Pro before, upgraded or a side grade, I don't know, to a UDM-SE, and this is what I run all of my network services on. So this is really the brains to my whole entire network. This is where I manage all of my Unify devices, all of my clients that I have throughout my network, as well as security, firewall, see insights, and I even manage my VLANs here. Now I moved to Unify last year, so I've been on Unify this whole entire year, and things have been mostly great. There's a few bugs here and there, but for the most part, they've been revving and pushing out new features faster than ever. And I love to be able to manage everything from a single pane of glass. I say that a lot, but I do. I can manage all of my switches, all of my ports, all of my firmware, all of my reboots, cycling, updating, you name it, all from here. Even my cameras, which we'll talk about here in a little bit. But I do have some plans to bring pfSense back into my network, or an internal firewall and another side project I have going on. But for now, it's Unify Network. On to home security. As I mentioned, I'm using Unify Protect. I had a UDM Pro and I wasn't using the Protect feature, but after thinking about it a little bit more, I decided to buy a couple of cameras, and then it turned into me going all in with Unify Protect. The nice part about Unify Protect is that it has on-device object detection, as well as on-premise video. So all of my video stays on this hard drive, it records, and I can view it from the cloud. I won't get into semantics about how much of the cloud it uses, but it does keep all of my video on this hard drive that's within my network. Now for containers. Containers. I'm running all kinds of containers, but I made some huge changes to my environment this year. As you may or may not know, I'm running Kubernetes. I did have 2 clusters at the beginning of this year, but I've recently moved to 3 clusters. Why do I need 3 clusters? How much time you got? So the reason why I have 3 clusters now is because my 3rd cluster replaced my Docker-only hosts. So for a while, I had multiple hosts that were running Docker containers that were managed by Portainer, which is fantastic. If you want a single Docker host and you manage it with Portainer, totally fine. It's great. But for me, I had more things in Kubernetes than I had in Docker. So for me, it was super challenging to manage my infrastructure one way in Kubernetes and then manage another part of my infrastructure another way with the plain old Docker way. So it was really challenging to manage those 2 environments, especially when I have lots of automation on the Kubernetes side and very little automation on the Docker-only host side. So I decided to migrate all of those Docker containers into a new, smaller cluster, and now they're running inside of there. So let's talk through it really quick. As you can see here, I have 3 clusters, one called local, one called cluster 01, and one called cluster 02. Let's talk about local first. So this local cluster is dedicated to running Rancher. That's it, that's all that runs on it is Rancher only. And this acts as an upstream cluster so I can provision and manage downstream clusters, which we'll talk about. But really, this is just for management. And I have this all backed by Git Ops too. We'll talk about that in a little bit. But I really use the UI really just as a dashboard for all of my Kubernetes clusters. So you can see here, this is just my Rancher cluster. This is running on top of K3s and it's dedicated to Rancher only. Then we have cluster 01, which is my user workload cluster. This is where all of the stuff I want to run in Kubernetes runs. And this is the same cluster that I've been running for a couple years now. It's just grown. As you saw, I had more nodes, but that's the nice thing about Kubernetes. I add more nodes as I run out of compute or disk space or even RAM, and it will add that node to the cluster and even everything out and make my services highly available. They'll eventually move over to that node as they need to. But within this cluster, I have many things that we're going to talk about, like reverse proxies, CMS systems, monitoring systems, Grafana, Prometheus, you name it, it's all running inside of Kubernetes. And this cluster, not that it matters, is RKE1, which is Rancher's Kubernetes engine, the first version of it. And we'll cover the services that are running here. Just know that almost every single one of my services is running in Kubernetes. So then we have cluster 02, and you can see I named this internal. So this is a cluster that's totally segmented from my network on a different VLAN that's mainly for running internal only services. So think traffic internal, so only internal services that I plan to use, not ones that I host public, or Homebridge or Home Assistant or services like that. Anything that I want to have internal only is going to be in this cluster. So really the only thing I have running in here now is one instance of traffic. And that was done purposely because I used to have an internal version of traffic running on Docker. And that was the way that I accessed my internal services. I didn't want to go over into a different VLAN to my other Kubernetes cluster to connect to there, to terminate to SSL, to then come back to a trusted network. And after thinking about it long and hard, I thought, well, the easiest thing to do, is create a new cluster on the trusted network and then put my traffic or my reverse proxy in there along with Cert Manager so that I didn't have to VLAN hop back and forth to get to my reverse proxy. So this cluster is running on my trusted network, and then it has access to the services it needs for the reverse proxy. And then so I don't have to create a whole bunch of firewall rules to go back and forth between VLANs, and makes it kind of very complicated. So while we're talking about Kubernetes, I may as well talk about Kubernetes Storage. I've had quite a few changes to Kubernetes Storage over this past year. So at first I was kind of doing a little bit of Longhorn, and then I went all in with NFS, and now I'm back all in, 100% all in with Longhorn. So here's why. At first I thought, hey, I'll use Longhorn for the storage that I need highly available, and then I'll use NFS for anything else I don't need highly available, because I don't have a highly available NFS share. I only have one instance of TrueNAS. The nice thing about Longhorn is I get highly available storage because it creates replicas of this block storage within the cluster. And then I started getting confused as to why I didn't want everything highly available. If I had to reboot my TrueNAS, I would lose some of my configs that I thought I didn't need highly available, and then my cluster would start rebooting those pods and my services would start to go offline. But I've gone all in with Longhorn now, and it's actually been totally fine. I actually enjoy it quite a bit. So it's super nice having block storage within your cluster versus NFS, which is nice most of the time, but a lot of things don't work well with NFS when it comes to permissions or databases or database locks and things like that. I ran into so many odd issues that I finally threw it out the window and went all in with Longhorn. And then all of those weird permission issues, totally gone with Longhorn because it's block storage. Pod has direct access to that volume and can read and write to it. And as far as Longhorn goes, it's great as long as you use it for the intended use case. Now, what do I mean by that? I mean, typically Kubernetes storage isn't your whole entire media collection. Maybe it is, but you have to think about those types of things if you're gonna do replicated storage, no matter what system you use. And so I don't think that, Longhorn itself is a good use case for your media collection within Kubernetes, because it's going to replicate that media collection across all nodes, and it just makes things super complicated. But as you can see, I have some super small volumes, super small, 20 gig, 10 gig here, 1 gig here, and that's perfect for a lot of my services. And it's super easy and fast for it to replicate. So I keep 3 replicas of each volume within my cluster. Anytime something changes, it just synchronizes the replicas. Now you can imagine if you had 500 gigs and that changed often, you would have a lot of network activity and a lot of synchronization going on. Not to mention, you would be using 3 replicas of 500 gigs across your storage. So there's 1.5 terabytes that are just gone. So anyways, this isn't a Kubernetes storage lesson. Maybe it is, but just be sure that you're using Kubernetes storage for an appropriate use case. And if you want to use a service which needs your media collection, look at something like NFS or one of the other storage classes that doesn't replicate your storage across storage nodes. Anyways, next up is Git Ops. And Git Ops wasn't a topic last year. I added Git Ops to my environment this year. So Git Ops is this idea is treating your infrastructure as code and having Git be the driver of change to your environment. So what does that mean? So here is my Git Ops for home. I have my first cluster, my second cluster, and my local cluster. And all 3 of these clusters are treated as code. This was a huge game changer for me because I write lots of code for my day job and for my home job and YouTube job, whatever this is called. And for me, it was supernatural to be able to declaratively state how things should be. So the state of my cluster is all defined in code here. So for example, earlier today, 6 hours ago, I was fixing something with monitoring. I noticed that I wasn't getting node exporter or Prometheus data from some of my nodes. I realized that I had taints on these, and so I had to apply tolerations to say, hey, you can tolerate these taints. If you have these, ignore them and apply this node exporter sidecar to it so we can export things to Prometheus. And then I committed this code, pushed it up, 2-3 minutes later, it applied, and then I had metrics again for some of my nodes. And there are alternatives to Flux. There are things like Argo CD, which is a more visual way to do Git Ops, which I might be exploring this year, we'll see. But that would be a huge change for my cluster, but maybe on a test cluster, I don't know. If you want to see something on Argo CD, let me know. Another thing I've been using and haven't changed yet is Traffic. So Traffic is my reverse proxy for all of my HTTP services. Now I actually have 3 instances of Traffic in my environment, and I actually had to look at my notes to figure out that I wasn't using 4 anymore. And if you don't know what a reverse proxy is, it's the opposite of a forward proxy, but it's one endpoint that you can send requests to that will then inspect that request and send that to the appropriate service or container in my instance. For example, if I want to say rancher.example.com and point that to my reverse proxy, that will route it to my Rancher container. And if I want to say uptimekuma.example.com and it's pointed at that same reverse proxy, it can inspect that request and then route that request to that service. So I have 3 of these. I used to have 4, but I have 3 of these. 2 of these are in my public Kubernetes cluster. 1 is exposed to the public and 1 is exposed internally. And so that's so I don't have to go out through the firewall and back in. And it allows me to refer to my services internally one way and then refer to them externally another way. Also, it makes firewalling and security a lot better. I know that managing 2 instances of traffic within one cluster is kind of weird, but for me, I wanted to separate my concerns and know that, hey, if I expose something on my public version of traffic, that's for public, and if I do something on the internal, that's internal only. So then, I used to have 2 versions of traffic running on Docker. So I had those load balanced on kubevip, and so that if one thing went down, the other one would pick it up. But now I've moved that all to my new Kubernetes cluster, and that has HA built in. So I don't have to use keep-alive-d. I think I said kubevip earlier, but I meant keep-alive-d. I don't have to use that as a VIP within Kubernetes because I can run traffic highly available within that cluster. So anyways, even though I made it a little more complicated By putting it inside of another cluster in Kubernetes, I reduce the complexity or the manual automation that I had in place by running 2 Docker hosts with Keep Alive D with a VIP. So anyways, I have lots of tutorials on Traffic. I'm sure that's how a lot of you found me, but Traffic is the reverse proxy that I'm still using. So speaking of reverse proxies, I also use Cloudflare for my external reverse proxy. So I kind of have a double reverse proxy. So all of my DNS records point to Cloudflare, which gives me protection and hides my public IP. So they bear the brunt of all the exploits and attacks. And if it gets through to Cloudflare, then it sends it down to my reverse proxy where I do something similar too. And it also obfuscates or hides my public IP, which is super nice too. For monitoring, I use a few things, but for uptime status, I use Uptime Kuma. Uptime Kuma is a great open source project that allows you to monitor different services. You can monitor things like HTTP for websites, TCP, UDP, even DNS. You could even do pushes. You could monitor Steam collections. You could monitor all kinds of things. And it's really an open source alternative to Uptime Robot. And it looks like that too, and it runs great, and it's all self-hosted. And you can see I'm monitoring a lot of my services here. Ooh, a lot of them with 100% uptime. Well, Uptime Kuma is fantastic for self-hosting. And if any of my services go down, I have webhooks set up to send alerts to Discord to let me know. Next up is data visualization, and this kind of falls in the realm of visualizing data as well as metrics. So I use Grafana along with Prometheus to scrape metrics from all of my nodes and all of my services, and then put them in a fancy dashboard like this. Grafana is fantastic once you get it set up. Not gonna lie, it's challenging to get it set up, and there are a lot of moving parts. I did a video on this for Kubernetes, and I think I have one on Docker as well. You should check it out if you're interested. But once you have it set up, it's fantastic. There's so much data you can get from these charts. So I can not only visualize my data here, but I can also set up alerts with Alert Manager. Say for instance, if my memory usage exceeds 80%, I can set up an alert based on that metric. Again, it's pretty dense stuff, but once you have it set up, it's fantastic. Plus, it's like so cool to look at these charts. While we're on the topic of Grafana and Prometheus, we should talk about logging too. So I set up logging in my system earlier this year, and I settled on Loki. And Loki is actually fantastic for logging. It's pretty lightweight, all things considered, compared to other logging solutions. But I think one of the best things about Loki is that it follows this container model, so kind of container first or cloud native. What I mean by that is that most containers write out to standard out when they have logs. They log it out to a console. And then so Loki, along with Promtail, can scrape that data from standard out and then pipe it into Prometheus and then give it to me in Grafana, which is kind of nice because I'm already in this Grafana ecosystem. For example, if I said app, alert manager, and I wanted to see the logs, I can search all logs for Alert Manager, and here they are. Now you have to learn a special syntax, but as you saw, it's going to suggest different labels and things that it's already indexed. But if you switch into Builder View, they're actually making this a little more user-friendly and making it UI-driven if you don't want to use their log query syntax. Now, I know that there are more logging systems out there, but for me, I wanted to use something that's already in the Grafana ecosystem that I can use at home and learn more about. I've used all kinds of logging systems everywhere, and they're huge and gigantic. And so I wanted to learn something I haven't used before, and I've been pleasantly surprised by it. Next up is home automation. So I've been on a journey with home automation. I've done everything from Home Assistant to Google Home to HomeKit to Bridges for HomeKit, and I don't know where I'm at right now. No, I know where I'm at right now. So I've done lots of things with home automation. I've written even custom containers for it, and I keep coming back to HomeKit, possibly enabled with Home Assistant once again. And the reason I mention this is because I use something called Home Bridge, which acts like a bridge to all of my IoT devices that don't support HomeKit. And so this runs in my network. It's actually running in Kubernetes and gives me all of those devices within HomeKit. But soon, I think I'm going to switch from just using this HomeBridge container to using Home Assistant. So then I can bridge my existing devices over to HomeKit and then get some of the additional features from Home Assistant as well. I've been back and forth on Home Assistant. I think this year I'm going to give it yet another try, especially in Kubernetes. And then I've even written my own custom code to control Broadlink devices to control different devices in my room, through this web UI or through an API. And that was really just for fun and for my live stream too. And that's another reason why I want to move to Home Assistant soon, is so that I can write code against a common API for those devices. Right now I write code against this Broadlink device, against my Philips Hue devices, and a few other devices I have in my environment. But if I could consolidate those and get those inside of Home Assistant, then I can write code against Home Assistant's API, and then I only have to write the code once or learn one API. Looking forward to it. As far as data synchronization goes, I'm still using SyncThing. SyncThing helps me sync data across different devices. Now, how do I use this? Well, I used to use it a lot more before this year. Before, I was using it to synchronize data from each of my Docker hosts. So my Docker Compose files, the backups for the local storage, or the mount paths, things like that. Configs, scripts, you name it. But now after moving to Kubernetes, I don't need to do that anymore, so I have less use for SyncThing. I still use it to synchronize a lot of my YouTube stuff onto another box just so I have another local copy of it, and then that gets backed up to the cloud. But SyncThing is fantastic to do that. I think with my new NAS coming, I might not need SyncThing as much. Next is a link page. I think last year I classified this as self-promotion because I didn't know what to classify it as, but really it's a link aggregation site. Not that many people need this, but a lot of people do. You see it across Instagram and Twitter. You'll see link in bio, and usually that link in bio is Linktree or something similar. Well, I created an open source alternative to Linktree that you can self-host yourself. And so this is my Little Link server, which is based on Little Link, and I'm still using this. As you can see, my social buttons have grown, but I'm still using it. It's open source, it's on GitHub, and I build Docker containers for all processor architectures on every single pull request and merge. And so if you need a quick links page, check out my Little Link server. Next is a link shortener, and I've chosen Shlink for my link shortener. It's actually really awesome, super stable. I've been using it for a long time, and you may or may not have a use case for this. So I don't really need to shorten links as much as I need to control where these URLs redirect to. So this allows me to create a link and then control where you get redirected to when you click on that link. And this is great for anything that can change at any time, like Discord invite links or some of my affiliate links. And so I put these behind links so that I control where they go. There are quite a few link shorteners out there, but I love Shlink because it's super modern, uses Postgres, and it's open source. So if you need a link shortener, you should totally check it out. For home entertainment and media streaming, I use Plex. I've been using it for years. I've had Plex Lifetime for a long time. There was a time when they offered Plex Lifetime for half off the OG price, and I couldn't say no. I think I got my money's worth. But fantastic solution. I know that there are other ones out there, especially free and open source, but I've already paid for this and it works great. So this is running on a virtual machine, and on that virtual machine, I pass through a GPU to the Plex service so that in the rare case that it needs to be transcoded, it can use my NVIDIA GPU. But rock solid, couldn't ask for a better solution. UPS battery monitoring. Such a specific category, but I had that category last time, so I gotta have it again. I'm still using NUT server or network UPS tools. Now it can be a pain to configure and get set up, but once you have it set up, it's fantastic. Now I use this to monitor my UPSs, to coordinate shutdowns and coordinate power-ons. However, I just got some new UPSs, so I don't have any of this configured. So I'm gonna see if I can make that a little bit easier this time around, but absolutely I'm gonna use NUT server again, because it's one of the few things out there that does this. In the CMS category, I'm actually running quite a few CMSs. I wish I can consolidate down to one or two, but I can't. So I am running WordPress for one of my blogs. I've actually been running it for years and years and years. It's one of the first things I self-hosted. That's still out there. I'm self-hosting my wife's portfolio, which is actually running on Ghostblog, which is super duper nice, especially for her. Then I'm running Wiki.js, which is a public wiki for our Discord community, and people can add and contribute to this wiki as they see fit. And so those are the three content management systems I'm using. I would love to get down to one like Ghost only, but Ghost doesn't have a ton of flexibility with plugins, whereas WordPress has way too many plugins. So there's definitely a trade-off. Anyways, I'll be looking to see if I can consolidate those next year too. Next is just plain old websites. So not CMS systems, but actually websites that I build and deploy and host here. So I have lots of them, ones that are built on Hugo or Jekyll, like my documentation site, and some that are just custom websites that I built using React.js, either client-side or server-side. But I have lots of little websites that I build and host within my cluster. So next is dynamic DNS, and so this is how external records resolve to my public IP at home. So for dynamic DNS, I use Cloudflare, and I have a Docker container for each one of my domains. It will check to see what my public IP is. If it changes, it will use the Cloudflare API to update my public DNS record to point to my new IP addresses. And this is all automated and running inside of Kubernetes. I don't even think about it, ever. It just works. So next up is CI and CD, or continuous integration and continuous delivery, or continuous deployment. So the idea behind this is that you use source control for your code or infrastructure. You push that up and you run an integration on it. So you run some kind of CI job on it. So after that, if it passes CI or the continuous integration, then it will go on to continuous delivery, where it may deploy this code out to your infrastructure. So I use GitLab and GitHub for my source control. And a majority of my internal CI and CD runs on GitLab CI and CD. And I have these runners running within my Kubernetes cluster. So each time I commit some code, I push it up, it will run some tests on the code, it will build Docker containers, it will put them in a registry, and then it will tell Kubernetes to go and deploy or pull that container into the Kubernetes cluster. And then Kubernetes takes over and pulls one pod down, replaces it with a new pod with a new image, and then pulls the next one down, so on and so forth, and then my services stay up. And I also do that same thing with GitHub, and GitHub has GitHub Actions, and I have some GitHub Actions that are tied to code in GitHub, and I have GitHub Actions runners running within my Kubernetes cluster. I got a lot going on. So the takeaway here isn't which one you use, but just to have this mindset around CI and CD and say, hey, I'm gonna source control my stuff, and then when I push it up, I'm gonna run some actions, and then if it passes those actions, I'm gonna deploy it. And this is really a software development methodology. But anyways, I'm gonna see if I can consolidate some of this because I have some of my code in some places and some automation in other places. So maybe 2023 will be more consolidation. And then there's everything else. There's so much that I could probably talk for hours about everything else that I have going on. I have custom code for automation, as I mentioned. I have custom code for my lights. I have custom code running in that Raspberry Pi back there. I have code in containers running for bots on Twitch and Twitter and Discord, multiple bots for each of those services. I run the 100 Days of HomeLab website along with a bot there too. I even have an app that runs on Android and iOS that's in app stores, and the services are hosted here too. That's all backed by CI and CD in Kubernetes. There's a lot going on. But don't let any of this discourage you from hosting something within your HomeLab. It doesn't have to be big and ginormous, nor does it have to be custom code. It doesn't even have to be public facing. And it doesn't have to be in a container either. My recommendation to you is if you want to get started, start small and start with a goal in mind. Think of something that you want to run and self-host at home. Say something that's fun, like a game server. And then work backwards from there and think about what you need to host a game server. First, you need to select a game server. Then you need to decide if it's going to be containerized or not. Then you need to decide if you're going to run it bare metal or a virtual machine, and work your way backwards until you get to where you are. So then you have a plan moving forward on how to host things within your environment. So I hope you learned something today, and remember, if you found anything in this video helpful, don't forget to like and subscribe. Thanks for watching.